Hi everybody!
My name is Itumeleng, and I'm a junior software developer at Virtual Rabbit. This project is basically a replication of the Sonoff Smart Switch, but using our own development board means we can easily add or remove components later on. Over here we've got our one channel relay module. On the one side it should have 3 pins. The one I have here has S plus and minus, and in others it should be ground, VCC, and one more pin module which should be like SIG or something else, or 5V or something. And then on the other side we have our normally closed and our normally open gates, and I'll explain later on in the video what those are and how they work. The development board I'll be using for this build is the ESP8266. Its low cost, size, and built-in Wi-Fi support makes it the ideal candidate for this project. You can get away with using different development boards as well. The best substitute for this board would be the ESP32. You could also use a Raspberry Pi, but it would be a bit more work, and I have not catered for that in this build. Next, we need a working device that we wish to turn on and off remotely. I've used an old lamp for this, but anything where you can split a wire would do. Just keep in mind that once the wire is split, it will probably never look the same again. We want to find a good spot on the cable to expose a bit of the wire. I used a potato peeler to do this, but you can use whatever you so desire. And yeah, it should look like this when you're done with one tiny split. And this is what we are going to put into the normally open and normally closed gates of the relay that we spoke about earlier. We're going to need female to female jumper wires to connect the relay module to the node MCU. We're going to stick some of these in the pins, the 3 pins we mentioned earlier, the positive, the negative, and the S on the relay board to the node MCU. We're going to connect the negative pin on the relay board to any 3v3 on the development module, and we're going to connect the plus to a ground, and then we're going to create the S, or whatever pin is left, to pin D5, which is GPIO 14 on this diagram here. The first 2 pins, the negative and the positive, are responsible for powering the relay module, and the last one is responsible for turning it off and on, which is something we will do in the next part in the Arduino IDE. We will be making use of 2 different applications to build this project. The first is the Arduino IDE, which we'll use to write all our code. And the second is the Blink app, which we'll use to control our relay from our device. So I'm not going to show you how to install the Arduino IDE, but there should be instructions on their webpage, or a quick Google search on how to install the IDE would be just as easy. Once we've got the IDE installed, we need to add a library to the IDE for the ESP8266. So what we can do is quickly Google search. And if you follow my Google search here, the first page should have the information that we need. What we need is to scroll down and find this URL here. And then we need to copy that and go back to our IDE, go File Preferences, and then in Preferences, there should be an additional boards manager URLs at the bottom. And then we just need to paste that into that and then click OK. And we then need to add the board to the IDE. So go to Tools, go to Board, and go to Board Manager. And then type in ESP8266 and install the one by the ESP8266 community. We are now going to write some code to switch the relay on and off from our computer. What you should have now is an empty sketch with setup and loop or some example code. If you do have example code, start a new one and write the code that I have here. What we're going to do in the setup is we're going to set our serial baud rate to 9600. And we're going to set our pin mode to 14, which is that GPIO pin that we put our jumper cable in earlier. In our loop function, we're going to check if our serial is available, and if it is, we're going to read the values. So we're either going to send in a 0 or a 1. And in this case, the 0 switches the pin on and the 1 switches it off, but the order doesn't really matter. We just need to check if we can actually turn the light on and off. To open your serial monitor, click on the magnifying glass on the top right corner of the screen, and then you can send in the 0 and the 1 to check if the light goes on and off. And if it does go right, if it works, you should have something that looks like this. Now that we're done with the Arduino IDE part, we need to download the Blink app to our mobile device. So now that we've downloaded the app, we need to create an account. And then once that's done, we need to create a new project. Once the project is created, they will email us an authentication token, which we will use in our code later on. We need to add a button to our project. So we will click on the plus sign in the app bar to get our widget box menu. And then we will click on button. We should now see a button on our screen with the word off written on it. And then we need to click on that. And then we need to toggle the slider from a push button to a switch button. And then we click the pin option that's there and set the digital pin to GPIO 14. Before we can continue writing the code to communicate with our Blink app, we need to install the Blink library to our Arduino IDE. So for that, we need to go to Tools and then Manage Libraries. And then we just need to type in Blink and make sure we install the first one that's there. Now that we have the library installed, we can use one of the Blink example codes that they've provided for us. So what we need to do is go to File, Examples, Blink, Boards Wi-Fi, and then we just need to do a few more things. We need to replace SSID1 and pass with our Wi-Fi SSID and the password to it. And then we need to replace auth1 with the auth token that we just copied from our email. And then when we're done with that, we just verify the code and then upload it onto the development board. Once we're done with that, we can go back to the Blink app and go back into our project, press the play button, and then just toggle the switch on and off. And with that, we should be done with our project. We're going to link our Blink app to Google Assistant with the help of the IFTTT website. First thing I recommend doing is getting the Blink Cloud IP address, and to do this we can just ping it. So once we've done that, we need to go on to the IFTTT website, so ifttt.com, and you can sign up. I signed up using Google, and then once you're on there, what you want to do is just go to create, and you should be on the same screen that I'm on right now. So if this in this case is Google Assistant, so we need to go in, look for the Google Assistant service, and then we just need to type in some of the phrases that we want to turn our light on. Once we've set up our Google Assist phrases, we need to set up our then that, which in this case is a webhook, which is triggered when the command comes in and toggles our blink button. For our URL, you can just type in HTTPS followed by the IP address that we got for the Blink Cloud earlier, and we need to then enter in the authentication key for a Blink project, and then /update, and then pin D14 in this case. And then we need to change our method to put our content type to application.json, and then in the body we need to put in the 1, but please make sure to switch out those single quotes for double quotes. Cool. So now that we've done all of that, we need to just repeat the same process and do this for turning our light off. So we can copy the URL from the first applet and use it in this one, and then everything else remains the same besides the body, which we'll now be sending in a 0 to turn the light off instead of the 1 that we had there earlier. Cool. So once you've done that, you should have two applets. The one to turn the lights off and the one to turn the lights on. And with that, just make sure that they're both connected, and you should be able to call up Google Assistant and say one of those phrases and have the button toggled.